Tāne was born with cerebral palsy. This year, at 19 years old, he stood on the podium at High Rocks, Auckland, third place in his division. An adaptive athlete who couldn't walk unaided at 5. With massive advances in artificial intelligence in the past couple of years, it's now possible to know more about his condition than was possible in the previous 17. This channel is going to figure out what's possible in real time using artificial intelligence. We're going to talk about neuroscience, genetics, training, AI, all of it. But mostly we're going to follow Tāne, because he's already doing things that seem to be impossible. Can AI provide new interventions and solutions to improve his condition? We're just getting started. Let's go and find out.
All right, let me tell you what's in this episode. Back in 2021, after years of investigation, we got a result. A single DNA letter, one letter, in a gene called KCNE5 was different in Oscar. That letter turns a keep building instruction into a stop here. And the thing is, in 2021, the lab said, we don't know what this means, variant of unknown significant. File closed, come back in 10 years. We're not waiting 10 years. In this episode, we're going to reopen Oscar's case using tools that didn't exist when this report was written. AI genome models, NTV3, EVO2. We're going to ask a question that wasn't possible to ask in 2021. Does the DNA itself think this change is significant? And the bigger question, the one that drives this whole channel is, can AI actually change outcomes for people with cerebral palsy? Not in theory, not in a research paper, but right now for real families. Let's find out. First of all, we're going to have a chat with Oscar to make sure he's comfortable with what we're doing. Most people watching this, if you watched the first episode, will know that this channel is about Tāne, or Oscar.
Yeah.
He's the guy that's dragged us into High Rocks, and
No, my dad dragged me into High Rock because I was so unfair.
right, okay, all right. So I may have dragged him into High Rocks, but now he's well and truly into it.
Yeah.
So, as you know, he's doing adaptive High Rocks, and therefore, you know, he has a pretty serious medical backstory. Didn't really talked about it publicly before, but I guess this is the opportunity on this channel to really talk about it and to sort of start and show people what we've gone down as a sort of medical mystery that we have been trying to solve since he's been born. So, you know, this whole project Tāne takes on, you know, we're going to go deep into medical research, interventions, things that might change how your body works. Some of it is pretty crazy, pretty wild. So before we get there, I need people to understand something about Oscar. So, you know, are you happy right now?
Yes, mostly happy.
So mostly he's happy. So if nothing changed, medical interventions can't.
I can ride the bike and ride the scooter and all that.
Right, so that's, you know, so he's just saying there he wishes he could ride a bike, ride a scooter. So he wishes he could ride a scooter, ride a bike. What I wanted to get on camera before we start talking about medical interventions, stem cells, nerve regeneration, whatever, gene therapy, you know, people are going to think this is some sort of miracle cure story, but it might not be. It's a, you know, it's a mystery. It's a medical journey, I guess, that we're going on. So, yeah, I just want people to know that, yeah, you want to be able to ride a bike.
Yeah.
Anything else that would be neat?
And do snowboard normal.
Well, you're pretty good at snowboarding. What do you think you get wrong on your snowboarding?
My toe edge.
Your toe edge,
Yeah.
yes.
Yeah.
I think if you could crack the toe edge,
Yeah.
you would absolutely be... You already tear down a mountain, but that would make a big difference. And that's really going to lead us down a pretty interesting journey. So, so look, let's get into it.
Yeah. Hell yeah.
Hell yeah.
Yeah.
All right. Okay. So this is where things get really interesting and really exciting. So the way that I've approached this is somebody, that's an AI engineer. Is the advances over the last 12 months have been pretty crazy in AI in terms of what's been possible and the models that have been released and the power of those models. So the first thing I did was I built an AI application so that it could actually know everything about Tāne. So I built an AI agent that lives up in the cloud, that's job is just to know everything about his medical condition. I took all of his medical notes. You can see here we have medical notes since he was born, and I added them, broke them all down and added them into a semantic search database running inside of this agent so that it's got all of this knowledge in really fine granular detail. And then I went out and said, okay, we know we've got this gene issue that we need to, could potentially be something that we can start to go down a track with. I instantly thought, right, are there any AI genome models that we could use that could start to tell us about this gene or what's happening? We've got the software issue. We know we've got this piece of evidence, which is to say that it's found, a gene problem. So I built this genome gene explorer, behavior explorer, because what we're trying to do, and when I started looking up these models, it will tell you that if this gene doesn't function right, this is what will happen in the human body. So you can start to understand, okay, if that's going to happen, is this the sort of symptoms that we see and behavior that we see in Oscar? So look, so we're just in research mode here. I've got the gene. I can load the gene. I can load Oscar's variant of the gene. I can, it stops at position 54. I can start to understand what's happening. It can start to predict some of the outcomes. We can look at the functions and what happens. And then we can look at potential therapeutic space. And again, I think we'll get to this as we get into different episodes. And this one is very much about sort of setting the scene, right? So let's just have a look at the clues and where we're going from on here. So clue 1 of 5. For him, one DNA letter creates a stop signal. So that's a protein instruction. It stops there. So we know that. So that's our first known thing. Second possible consequence, clue number 2, the stop appears near the beginning. KCNE5 normally encodes a protein 142 amino acids long. It stops 19, so it stops very early. So we know that. So this sequence predicts an early stop. What the cell actually does with the faulty message requires biological testing. And again, I will get to that in future episodes because we've been looking at what we need to do here. So that's a fact. Clue number 3. Does the model find this letter change unusual? So that's the first thing that we wanted to use these models. And I've got 2 models loaded. The NTV3 genome model, and I've got the EVO2 genome model. And so there are a number of different models, which again I will cover off as these episodes go along. So let's just analyze Oscar's change. So now it's found something in the model. Let's use AI and see what it says. Does the model find this letter change unusual? The change T was about 15 times less expected than the original G. So again, what does that mean? That's what we're going to find out as we work through this channel, is what does it mean? And it did find it unusual in this location. It's a clue. It's not proof that it caused his condition, but it's a clue for us. Next clue, which DNA letter does this model expect? So again, it's amazing that we have these AI genome models before. So 54% of the time, it expects C. 36% of the time, it expects an A. 10% of the time, it expects a G. And 0.6% of the time, that model says it should get a T. Other letters in the DNA sequence should have been there, and in his one, it's not. And look, our final clue, I guess, for this episode, the stop signal is biologically important, and the sequence model can tell us whether the changed letter looks unusual. Neither result alone establishes that gene explains his condition, but we've established some facts. The DNA changes creates a premature stop instruction. The model measures with the change is unexpected locally, and still unknown whether that variant altered the function and altered, his bodily function in terms of his motor skills, and did it contribute to his phenotype. So next we've got to investigate where it's active, what the protein does, what evidence it supports or argues against this hypothesis around what's going on, and then start to look at, are there possible treatments? And when we've looked at it, certainly, this does open up some opportunities. That's it for this episode. It's really a teaser of where we're going with this, and as medical science advances with the exponential aid of AI, we think this is going to be an incredibly exciting journey, not just for Oscar and for us, but for anybody that's trying to understand issues that they may have with themselves or their loved ones. So stay tuned, hit the subscribe button, and we'll be doing regular episodes as we go through this, this medical mystery. Thank you.